Chapter 9, number 58. A bullet of mass m is fired into a block of mass m, initially at rest at the edge of a frictionless table of height h. Figure 58. The bullet remains in the block, and after impact, the block lands a distance of d from the bottom of the table. Determine the initial speed of the bullet. First, we are given that the bullet mass is represented by lowercase m. The block mass is represented by uppercase m. The table height is represented by h. And the distance the block falls away from the table is represented by d. In this problem, we are asked to find the initial speed of the bullet, which is represented by velocity initial. And in the equation representing velocity initial, we are to only use the given numbers or letters. To find velocity initial, we must first start with this equation. Lowercase m times velocity initial equals parentheses uppercase m plus lowercase m parentheses times velocity final. When you rearrange the equation so that it equals velocity initial, it should look just like this. Next, we use these equations, where distance equals velocity final times time, and h equals 1/2 gravity times time squared. When you rearrange the height formula, you will get time equals the square root of 2 times h divided by gravity. When you rearrange the distance formula, you will get velocity final equals distance divided by time. Now that you have gotten velocity final equals distance divided by time, if you substitute for time, you will get distance times the square root of g divided by 2h. Once you get d times the square root of g divided by 2h, you can simplify the equation by putting d inside the square root, making it the square root of g times d squared divided by 2h. Now that we have gotten velocity final in the terms that were given, we can now plug it into our velocity initial equation, which is equal to uppercase m plus lowercase m divided by lowercase m times velocity final. When you plug in velocity final, you should get velocity initial equals uppercase m plus lowercase m divided by lowercase m times the square root of g times d squared divided by 2h.